In this video, I'm going to show you how you can use the Flood Modeler API to extract lots of data from ReFH2 CSVs and build them into a bunch of IEDs with Qt boundaries. So this is a task that I've done quite a few times before in the past, and when you do it manually, it can be quite time consuming and involves lots of copying and pasting from CSVs into Qt boundaries. So in this example, I've got some sample extracted data here from ReFH2, and this is in the sort of typical format where we have an index of time and then a bunch of columns for various return periods. And in this case, it's this total flow column that we want to bring into our Qt boundaries. So essentially, we're trying to transpose the data here so that we're going from a CSV with multiple return periods into multiple IEDs for each return period, and within them lots of different Qt boundaries. So I'm going to do this inside the code space. So if you've not watched the last video, have a look at that for how you can access the code space. But for this example, there is already a sample script called import ReFH CSV extract, which takes us most of the way. So there are a couple things that I want to change in this script for this example, but I'm going to show you what I'm changing. The main thing is that this script is set up to read node labels and storm durations from the file name. So if there was an underscore and then a storm duration after, it would split that into different IEDs. But in this case, we only have the node labels we want to work with. So what I'm going to do is actually remove the references to storm durations. And we only want to use the stem of the file, which is essentially the name without the extension. So I'm just going to remove those references to storm duration. So I've removed it from where it picks up from the file name here, and I'm also going to move this into here and remove this line. And then there's a couple of other places that I just want to remove the reference to storm duration. So here, and down here as well. So I'm just going to have a quick check that this looks okay. Yep, I think that's okay. And the last thing I need to do is actually reference where the data is. So because we're in the code space, I can't just access the data from normal Windows Explorer. But what I can do is actually copy this data and just drag it in to the code space, and you'll see it's now appeared here within the code space. So I'm going to right click this folder, copy the relative path, and just paste that into this link. So what I'm going to do to start with is just run this script as is, and I'll just show you what it produces, and then I can go through a bit more detail of what's actually happening. So if I click the play button up here, it should just run the script. And you'll see it's then finished that, and it's created a new folder called output. And we have an IED file for each return period. And if I look at one of these, you'll see we have lots of different Qt boundaries inside this IED file. So if you open this in Flood Modeler now, you would see all these different units, and it would there for each return period. So that's how fast it takes to just run it. But what I'm going to do is just show you a bit more detail of what's happening at each stage, which hopefully gives you a better understanding of what the script is doing. So I'm just going to delete this output folder now again. So we're starting again with just these CSV files. And what I'm going to do now is actually run it in something called debug mode. So instead of pressing the play here, I can run, instead of a run Python file, I can do debug Python file. And this is a great way of running code to see what's happening, because it allows you to essentially step through it line by line, and you can see what's going on at each step. So to start with, we've skipped these for now, but we're importing a couple of different libraries. So importing from the pathlib library, which allows us to work with file paths. We're importing from pandas, which is for working with data frames. And then also from the Flood Modeler API, we're getting the IED class and then the Qt boundary unit class. So first step in here is just setting the folder where our CSVs are. So this is essentially pointing to the path to that folder and wrapping it in this path class, which allows us to do a few more things with it. I'm also creating an empty dictionary here, which is going to be used to sort of track our IED file paths as they're made. So this is entering the main loop of this script. So what I'm doing here is looping through each CSV file inside that CSV folder, and I'm doing that by using this glob method and passing in an asterisk here, which means basically get all the files that sit within this CSV folder. So it's going to loop through all of them. And since all the files that are in there are just these CSVs, then it's basically going to loop through each of these CSV files. So I'm going to step over again. And so what I'm pressing up here is this little command bar that allows us to either play, which will just play through the script, or step over, which allows us to step over each line. You can also go into and out of functions if you want to go deeper into the code. We can also restart and stop. So at this point, I'm inside the loop here, so I've got a CSV file, and I'm using this .stem attribute to get the node label. So what's useful about the debug mode is that you can go into this debug console at any point as well and just write in some code. So you can see here at this point our CSV file is this CSV, and so when we do .stem, it basically gets the name of the file without the extension. In this case, we're using as our node label. We're then going to use the pandas module to read that CSV. So at the moment, we're just looking at the file path. So now we're actually going to read the CSV and set the index to 0, which is the first column, which is the time. And so when that's read in, we essentially have this object, which is the full data frame of this CSV file. The next bit is a bit of a funky one because the time format in this CSV is not the same as the time format that we want for our Qt boundaries. What we're doing here is we're actually just changing the time index into essentially a number of hours. So we're creating a time delta on the index and then dividing it by essentially a 1 hour time delta. And so what this looks like on its own would be like this. So it creates an index where it's essentially the number of hours that are being for each step. And we're then overriding our index with this. So ultimately what that does is it changes our data frame so that the time index is just simply in hours. So it's easier to then convert it into a Qt boundary. The next line here, another a bit of a complicated one, is what we're essentially collecting all the different return periods that are present inside the CSV. Let me just check that. One second, I'm just going to rerun this quickly. So I just overwrote the index by running it again. So I'm just rereading it and rewriting that out. So now we've got our data as we want. So essentially what this is doing is it's trying to get the return periods out. So the way that I'm doing this is I'm actually going to use what's called a list comprehension, and I'm looping through each of the columns in our data frame. So if we just look at columns, for example, you'll see they look like that. And what I'm trying to do is essentially pull out this number. And so the number here comes at every 8 columns in the sort of standard structure. So when we look at every 8th column, it looks like this. And so we're splitting each of these column labels and taking the first part of it, so essentially this number, and then turning it into an integer. So when we actually run this together, we get this return periods object, which looks like this. So what we're doing now is we're going to loop through each return period, So for each return period in this list of return periods, you'll see the first one we loop through is return period 2. You can see here. So this is where we want to actually get the data. So the way that we're doing this is we are accessing the data and then accessing the column that's called total flow, and then passing in the return period here dynamically, and then this urbanized model. So when we run that, we get the flow data out, which looks like this. So now this is a pandas series where we've got the time index and then the flow value for the return period we're after, which is the 2-year. So this is the first stage now where we're actually going to interact with the flood modeler API. And what we want to do here is just create a Qt boundary. And this is as simple as calling the Qt boundary class, passing in a name, which is the node label, and passing in the data, which is this flow data. And so what this will do is it will create us a Qt BDY variable. So if we just have a look at what that looks like, you'll see here it's a unit class Qt boundary, and it's got a name. And we can actually print this with the print command, and it will print out the DAT file representation of this unit, which looks like this. So at this stage, we've created our Qt boundary, and we now need to start adding these to our IED files. And so the way we're doing this is we're going to start tracking them with this dictionary. So because we're essentially generating a new IED for each return period, but then when we get to the next CSV, we want to use the same IEDs we created in the previous loop. What we do is we just want to track the return periods in this dictionary. So if the return period has not been put into that dictionary yet, then we basically want to create a new IED file. You can ignore this line, it doesn't need to be in there, but we create a new IED file in the flood modeler API simply by calling the IED class with no inputs, and then we can run, if I just go through that, and then we can actually save the IED straight up with IED.save, and in this case we want to use the parent folder of where our CSVs are and create a new folder called output, and then we're just going to name the IED as Q and then the return period.IED. And then lastly, we just add that IED object back into our dictionary for that return period. So this will only trigger once per return period. So when we get to the next CSV, it won't have to trigger this block again because we would have already created them. So at this point, we just want to fetch the IED from the dictionary for the return period we've got. And so now we've got our IED file. At this point, there's no boundaries in it at all because we've not done the first loop yet. But if we look at IED.boundaries, we should have an empty set here of boundaries. And to add our Qt boundary to this IED file, all we need to do is pass in the node label as a key on boundaries, and then pass in that Qt boundary object. So we do that, and you'll see now if we look at IED.boundaries, we've got our first Qt boundary added, and then simply we just update the IED, so that just saves the IED in place, and that'll take us through to the next loop, and essentially we just let it repeat and let it loop through all these return periods and all the CSV files, and it will create all our IED files. So at this point, if we look in our output, we should have one IED file that only has one Qt boundary in, which we can see here. You can see the bottom of that. So what I'm going to do now is click play, and this will basically continue the script without breaking on any lines, and you should see all these new IED files appear. There we go. And so that script's finished, and again we've got all our IED files created with multiple Qt boundaries in. So that's a quick example of how you can take an existing script, edit it a little bit for how you need, and just run it in the code space. So at this point, I can actually right-click Output and download all of these IED files I've created back into Windows Explorer to use them.